Task number 2, we have a rectangle. No, we have a circle. Sorry, we have a circle. And inside the circle, we're going to place a rectangle. And we want to, the diameter of the circle is 5, and we want to place the rectangle such that we maximize the area of this rectangle. And the first thing we have to do then, or the best way to start here, is to put up the formula for what we are finding the area of, and the area of the rectangle is of course this side times this side, x times y. But we want the area as a function of x, and here we have two variables. We can't have two variables, so I need to get rid of this y here. And the thing is here, this y, there's a hint here. Y here is this is a right-sided triangle, and we know that from Pythagoras that x squared plus y squared is equal to 5 squared, which means that x squared plus 5 squared and y squared is equals to 25. And if I want to get rid of y here, I have to substitute y with something, and then I have to isolate y here. So I get y by itself on the left hand side, so I move x squared over here, so I get 25 minus x squared, and then I can write y is equals to plus minus square root of the right hand side like this. But y is a side in the rectangle, so it's not negative, so it has to be y is equals to 25 minus x squared. So then the area here will be x, this is this side, times y, but I now know that y is the same as 25 minus x squared. And then I have the area as a function of x. So that is was exercise 1 and 2 at the same time. And then we should use the and then we should maximize this area, right? It says to use the graph tool to find x, or the area of the rectangle is as wide. This is Google Translate, is as large as possible. It should be here, sorry. How big will this area be? So I have to find to maximize this area, so I have to find a maximum point, and that is of course easiest done by GeoGebra, by just writing in the graph, the function, sorry, and we write x times square root, Alt R, we get square root of 25 minus x squared, and we then get this graph, and we should just find the maximum point of this graph, and then we of course just press here and here and here, and we see that the maximum point at x coordinate 3.54, remember x here, that's one of the sides of the rectangle, and y, the function value, is the area. So the largest area possible is 12.5 when x is 3.54. So that is the answer here. To get as large a rectangle as possible, we need to have x should be x 3.54, and the area would then be 12.5. And then we should just use cost to find the same thing, which means I'm going to use cost to find the maximum point. And to find the maximum point, when I have drawn the graph here, I don't have to define it, it's already defined here. If I want to find the maximum point of this, I can just write exclamation and then a, and I get two answers. X can't be negative, can't have a negative side, so it's probably this is the maximum point. But let's just make sure it is a maximum point. If it says cost, we can't look at the graph. So I just check the mood of the graph when the x coordinate is 5 times square root of 2 divided by 2, and then c is negative, which means that the graph is angry, which means that this is actually a maximum point. So to maximize the area, x has to be 5 times square root of 2 divided by 2, which is the exact value of 3.54 here. And the area is then 25 over 2, which of course is the same as 12.5. So difference, when we do it graphically, we get decimal numbers. When we do it on cos, we get it exact with square roots and fractions and so on. So that was exercise 2.